what about a problem like this one? Let's look at, I don't think we really have done a ton of these. We did one in class with that demand function with, I think we were renting apartments or something. Here's one more. These are commercial cherry grower estimates from past records that if 15 trees are planted per acre, then each tree will yield an average of 39 pounds of cherries per season. If for each additional tree planted per acre, up to 22 additional trees, the average yield per tree is reduced by 1 pound for each additional tree, right, per acre. How many trees should be planted per acre to obtain the maximum yield per acre? So what could we do with that?
Wait, so if you plant 16 trees, you yield an average of 38 pounds?
Yes. Mm-hmm. Pretty hard to draw a picture here, but maybe we could define some variables at least. Number of trees per acre is probably going to be important, right? What are we going to call that? T? T for number of trees, I guess. Does that sound good? Okay, so T. So then, if that's true, what would we'll call the yield Y? What's Y going to equal? Say it again. Right. How could I calculate that? Actually, we're trying to find yield per acre. Sorry, that's all we're trying to do. That's what we're trying to find. Yield is maximum yield per acre. What are we going to do with that? What's that? Oh, I did. Thank you. Yes, I did. Whew. Yeah, I did. Okay, what are we going to do with this? I want you guys just take a second, visit with your neighbor. Let's see if you can come up with something.
So we're trying to figure out the yield. So the amount.
Right, because it tells you that if 15 trees are planted per acre, then each tree is going to yield 39 pounds, right? Make sense? Okay, what if I planted 16 trees? What would I multiply that by? 38, right? You get the idea? But we don't want to do this. I mean, you know, we're not just going to plug in individual values. We want to write a function here. So if T is the number of trees,
so what like T plus N times Y by Z?
something like that. Y as a function of T is going to equal T times what? How are we going to say this part? We want to multiply the number of trees times the yield per tree, which is given to us by this information right here. Whoops. How do I say that? I mean, what is... Yep.
Are we setting up the function for like just to practice calculus, or is it easier than to just multiply 15 by 30?
Well, I mean, no, it's not easier because you don't know. I mean, what if it's not a integer number of trees, for example, right? Or, I mean, what if this were, I mean, these are pretty small numbers, but what if they were in like the thousands or something? What, are you going to try them all? You know, I mean, you can't. So the question is, would you use, I mean, we could introduce a different variable, but let's not. Let's just do it in terms of T.
I mean like a constant that we just don't know.
No, we don't need to do that either. We don't need to do that. Say it again. Probably, yeah. Right. Can you say it in words? Because that's sometimes helpful. What are we multiplying by? We're multiplying by like this yield per acre, but sometimes it's difficult to jump right to a math expression. The yield is reduced by 1 for every what? Well, but it's not just every tree. It's every tree in excess of 15, right? So how would you say that? The number of trees in excess of 15. Say it again? Well, no, but you don't need any inequalities here. I just want to, how do you say that expression? The number of trees in excess of 15. So for example, if t were 22, what would the number in excess of 15 be? You did, but you meant to say, okay, so t minus 15, right? The number of trees minus 15 would give you the number of trees in excess of 15. Everybody get that? Yeah. Okay. So I'm for every tree in excess of 15, what is happening to the total yield? Oh, it's going down by 1. Aha. Okay. Okay. All right. Okay, so then how are we gonna say that?
Would it be, t times t minus 15 minus t? Oh, it would be 39 times.
Okay, there's something, right, so we got,
39 minus
whoops.
t minus 15, like in parentheses.
You might be
So,
Yeah, 39 minus the quantity. T minus
39 minus the quantity t minus 15, something like that. Does that make sense? Okay. And you can kind of test that out. What if t were 15? We'd just get 39. What if t were 16? We'd get 39 minus 1, right? That's working, isn't it? Everybody see that? Okay. So that's going to be my yield. Now, what would my domain be here? Okay, would it be 0 though?
No, it'd be 15.
Because really there's no sense, I mean, we can sort of shorten our domain up a little bit here because there's really no sense trying anything below 15, right? The yield is going to be 39 pounds per tree, whether I put in 1, 2, 3, 4, all the way up through 15. So why would you possibly put in something less than 15, right? Doesn't that make sense? Only when you get to 15 are things going to start to change in a way that's a little mysterious, because then you start to actually reduce the yield of each tree. Give me thumbs on that. Does that make sense? So really, there's no reason for us to start anywhere other than 15. And what would our maximum be? How'd you get 37? Okay, because we can only add 22 additional trees. Yeah. So 15 to 37. That's our problem, isn't it? Is that going to be a hard one or an easy one?
It's only one variable.
And it's when I distribute, I mean, I'm just going to get a polynomial out of this, right? Everybody agree? So this is really not too bad. If I distribute this negative and combine like terms, aren't I just getting y of t equals 15? I'm really adding 15, so t times 54 minus t, right? If I distribute the t, that's just 54t minus t squared, 37, whoops. On that domain, that's a polynomial. That's super easy, right? What's your critical number going to be? I mean, you can sort of anticipate what's going to happen here. We'll just make this one really short. What's our derivative? Okay, and y prime equals 0 at t equals what? 27. So that's our only critical number. what's the sign of the second derivative going to be?
No, it's gonna be.
Negative. It's a negative 2, isn't it? Right?
So it's a stack function, so that's
So if we were going to make a table here,
a sad function. So that's our maximum.
it's pretty straightforward. We go from 15 to 37. Our only critical number is at 27, which is a 0 with a negative second derivative. So what is it? It's a maximum, right? So if we've got a polynomial continuous function with only one interior maximum, one interior critical number, that's got to be the maximum if it's a maximum, right? Because the function's just going to do this, right? Everybody get that? Okay.
Per acre.
So 27 trees per acre is, if you're going in the cherry business, evidently that's what you do. You plant 27 trees per acre to maximize yield. How's that? Okay, you're welcome. Yeah, it's nice to know that stuff, huh?
That's mine, sorry.